What is Quantum Darwinism? Quantum Darwinism, a concept introduced by physicist Wojciech Zurek, offers a revolutionary perspective on how the classical world emerges from the quantum realm. Unlike traditional interpretations of quantum mechanics that center around the observer's role in collapsing the wave function, Quantum Darwinism focuses on the environment's role as a filter. According to this theory, the environment constantly interacts with quantum systems, amplifying certain quantum states while suppressing others. These amplified states become the ones that proliferate and are redundantly imprinted across the environment, allowing multiple observers to perceive a consistent reality without direct interaction. For example, the light reflecting off an object like an apple encodes redundant information about its quantum state, making the apple's color and shape observable by anyone who looks at it. Zurek's seminal 2009 paper emphasizes that this redundancy in environmental information is the cornerstone of classical reality. By allowing only the fittest quantum states to survive and proliferate, the environment creates a shared, objective reality that is accessible to consciousness. This framework not only deepens our understanding of quantum mechanics but also raises profound questions about the role of observers and the nature of reality itself. The role of decoherence, the environment as a selector. Decoherence plays a pivotal role in quantum Darwinism by explaining how quantum systems lose their strange, probabilistic behavior and appear classical. When a quantum system interacts with its environment, such as photons, air molecules, or other particles, its superposition states are suppressed, leaving only robust, stable states that can persist over time. This interaction effectively selects the quantum states that are observable, much like natural selection in biological evolution. Research conducted by Zurek and others has demonstrated that decoherence is not just a side effect, but an essential mechanism for the emergence of classical reality. For instance, experimental studies with quantum particles and optical systems have shown that when information about a quantum state is redundantly encoded in the environment, it becomes accessible to independent observers without disturbing the system. This means that the fittest states are those that can survive environmental interaction and be redundantly recorded, ensuring consistency in what we perceive. By acting as a selector, the environment not only shapes the quantum to classical transition, but also influences the framework within which consciousness operates, raising intriguing questions about the interplay between mind and matter. Redundancy as the foundation of reality. A cornerstone of quantum Darwinism is the redundancy of information, which ensures that the same quantum state can be accessed by multiple observers independently. This redundancy occurs when quantum systems interact with their environment, creating multiple imprints or witnesses to the same state. For example, when light bounces off an object, it scatters in all directions, carrying information about the object's quantum state. This redundant information allows different observers to perceive the same object in the same way, even without direct interaction. Zurek's research emphasizes that redundancy is not merely a byproduct, but a fundamental requirement for the stability of the classical world. Experiments with photons and quantum systems have shown how redundant encoding of information enables the emergence of a shared reality. Without redundancy, observers would experience vastly different realities, undermining the coherence of the classical world. By ensuring that specific states dominate and persist, redundancy bridges the quantum and classical realms, allowing consciousness to operate within a stable, consistent framework. This raises profound implications. If reality is built on redundancy, then our perception might be shaped by the states that have survived environmental filtering. Quantum Darwinism and objective reality. One of the most groundbreaking implications of quantum Darwinism is its explanation of objective reality. Traditionally, quantum mechanics has been criticized for its apparent reliance on a single observer to collapse the wave function, leading to questions about the subjectivity of reality. Quantum Darwinism resolves this by proposing that the environment itself creates an objective reality through the redundant selection and amplification of quantum states. This means that reality does not depend on any single observer, but is instead a consensus formed by the environment's interactions with quantum systems. Experimental evidence, such as studies on the behavior of photons in optical setups, supports the idea that redundant information encoded in the environment ensures that independent observers perceive the same outcomes. For example, when multiple people observe a tree, they all agree on its color and shape because the tree's quantum state has been redundantly encoded in the surrounding environment, such as in scattered light waves. This framework suggests that consciousness operates within a pre-selected reality rather than creating it, challenging traditional views of the observer's role in quantum mechanics. By shifting the focus to environmental interactions, quantum Darwinism provides a compelling explanation for the stability and objectivity of the world we experience. Implications for the multiverse and alternate realities. Quantum Darwinism not only explains our current reality, but also offers intriguing insights into the multiverse and alternate realities. If the environment selects certain quantum states to proliferate, it raises the question, what happens to the states that are not selected? Some physicists argue that these suppressed states could exist in alternate realities, governed by different environmental interactions. This idea aligns with the many worlds interpretation of quantum mechanics, which posits that every quantum decision spawns a new branch of the universe. Research into environmental selection supports the notion that different environments could give rise to entirely different realities, each with its own set of dominant quantum states. For instance, in a universe with different physical constants or interactions, the environment might select states that are invisible or incomprehensible to us. This perspective challenges our understanding of consciousness and its role in reality. If alternate realities are shaped by different environmental filters, could consciousness evolve to access or perceive these realms? Quantum Darwinism not only deepens our understanding of the universe, but also opens the door to exploring how reality itself might vary across different contexts. The philosophical and metaphysical implications. The implications of quantum Darwinism extend beyond physics, touching on philosophy and metaphysics. By suggesting that the environment selects and amplifies certain quantum states, quantum Darwinism challenges traditional notions of free will, agency, and the role of consciousness. If the reality we perceive is shaped by the survival of the fittest quantum states, then our understanding of individuality and creativity may need to be re-examined. Philosophers like Carlo Rovelli have argued that this perspective bridges the gap between subjective experience and objective reality, providing a framework for understanding how consciousness fits into the quantum world. Additionally, the participatory nature of quantum mechanics, as suggested by John Wheeler's participatory anthropic principle, aligns with quantum Darwinism's view of reality as a collaborative process between observers and the environment. This raises profound questions. Are we active participants in shaping reality, or are we merely interpreters of a pre-selected world? By redefining the relationship between consciousness, the environment, and reality, quantum Darwinism invites us to rethink our place in the cosmos and explore the deeper connections between mind, matter, and the universe.